It might sound like a question with a very simple answer, but why do buildings in colder climates consume more energy for heating? And why does the same building perform differently from one year to the next? One of the key tools we use to understand this is something called degree days. Degree days help translate weather data into meaningful information about heating and cooling demand. They are widely used in building design, energy analysis, and performance benchmarking. In this video, we'll explain what degree days are, how heating and cooling degree days work, how they're calculated, and why they're such a useful concept in building design and operation. Degree days are a way of measuring how much and for how long outdoor air temperatures deviate from a chosen base temperature. That base temperature represents the outdoor temperature at which a building typically requires no heating or cooling. When outdoor temperatures fall below the base temperature, we count heating degree days, or HDD, because there is a heating demand. When they rise above it, we count cooling degree days, or CDD, because there is a cooling demand. Instead of looking at temperature alone, degree days combine temperature and time, making them especially useful for energy analysis. The base temperature is a critical assumption in degree day calculations. It represents the outdoor temperature at which internal heat gains from occupants, equipment, and solar radiation are just enough to maintain indoor comfort without heating or cooling. A common base temperature is 18 degrees Celsius or 65 degrees Fahrenheit, but the correct base temperature depends on building type, insulation level, and usage patterns. Heating degree days reflect how much outdoor temperatures drop below the chosen base temperature, and therefore how much heating a building may require. Each day's contribution is the gap between the daily average temperature and the base, but only when the average falls below that threshold. For instance, with a base of 18 degrees Celsius and an average outdoor temperature of 10 degrees Celsius, the day adds 8 HDD. Summed over time, HDD values give a sense of how demanding the heating season is in a particular location. Larger totals signal colder climates and greater heating needs. Cooling degree days capture the opposite situation. This time we look at how far temperatures climb above the base temperature, indicating a potential need for cooling. When the average outdoor temperature exceeds the base, the difference becomes that day's CDD contribution. With the same 18 degrees Celsius base, a day averaging 24 degrees Celsius contributes 6 CDD. Accumulated over weeks or months, CDD values indicate hotter climates, or how significant the cooling season is, helping estimate air conditioning requirements and compare hot weather energy needs across climates. Degree days are used in many practical applications. They help estimate annual heating and cooling energy demand during early design stages. They allow energy consumption to be normalized for weather, making year-to-year comparisons more meaningful. They are also used in policy, building codes, and energy performance benchmarking. For example, dividing annual heating energy use by heating degree days can give a clearer picture of how efficiently a building performs, independent of climate variation. In building design, degree days provide valuable climate context. A location with high heating degree days typically benefits from strong insulation, airtight construction, and passive solar strategies. A location with high cooling degree days may require shading, natural ventilation, and low solar heat gain glazing. Degree days don't replace detailed energy simulations, but they are an effective first-order tool for understanding climate-driven energy demand. While useful, degree days have limitations. They do not account for solar radiation, wind, humidity, or occupant behavior. They also assume a linear relationship between temperature difference and energy use, which is a simplification. For complex buildings, degree days should be used alongside more detailed thermal and energy models. Degree days are a simple but powerful way to connect weather data to building energy demand. By combining temperature and time, they help us understand heating and cooling needs, compare climates, and evaluate building performance more fairly. They remind us that climate matters and that good design responds to it. If you enjoyed this video, give it a like, and if you want to learn more about building physics, comfort and performance, subscribe to this channel. Stay informed, stay inspired. TimberTalk.